Okay, so let's look at something called the degree of ionization and the percent ionization. Since we've already done a bunch of calculations for weak acid ionizations, I'm just going to use the work from examples 1 and examples 2 to kind of explain what degree of ionization and percent ionization are. So we're actually going to calculate the degree of ionization and the percent ionization for example 1, and then we'll calculate the degree of ionization and the percent of ionization for example 2. So first, let's define degree of ionization. So the degree of ionization is a ratio of ionized weak acid compared to the original initial concentration of weak acid. Ionized weak acid, this would be the conjugate base, A minus, at equilibrium, to the initial concentration of weak acid. So I would call that HA naught, which means initial, that little 0 degree sign down there. So it's a ratio of ionized to original. So ionized weak acid is essentially the conjugate base. Because that's how much broke apart. So if we look back at our example, so like here's the weak acid, here's how much of it broke apart. So the concentration of A minus here at equilibrium is going to be the amount of this weak acid that broke apart. This is the amount that broke apart, this is the amount that stayed together. So essentially it's a ratio of how much ionized, which is the same as saying broke apart. Another word that you might hear is dissociated, compared to the initial amount. Initial concentration. The degree of ionization. The amount that broke apart and the amount that stayed together. Okay, the percent ionization to get a percent, we just multiply by 100. Multiply by 100%, sorry, which is the same thing as dividing by 100. So if it's the degree of ionization, divided by 100. Multiplied by 100, sorry, times 100%. To get the percentage. Okay, so let's look at the examples. Let's do example 1 and example 2 and calculate the degree of ionization and the percent ionization. So here's example number 1. So this was the 0.1 molar solution of phenol, had a pH of 5.43. What is the Ka of phenol? So the information that we need from here is we need the initial concentration of the weak acid, and we need X essentially, which is the concentration that broke apart, the amount that broke apart. So I'm going to say it's the ionized over the original. I should have written this here too. So ionized is going to be the conjugate at equilibrium over the original, which is going to be HA initial. Okay, so the amount that ionized in example 1 is X, and X was 3.7 times 10 to the negative 6th. So the amount that ionized over the initial. So 3.7 times 10 to the negative 6th over the initial concentration of the acid that we started with, 0.1. So 3.7 times 10 to the negative 6th, it divided by 0.1 is 3.7 times 10 to the negative 5. This is the degree of ionization. The percent ionization is the degree of ionization times 100. So the percent ionization would be 3.7 times 10 to the negative 5 times 100 equals 3.7 times 10 to the negative 3rd percent, or it might make a little more sense to say 0.0037%. So what this is this is how much of that weak acid broke apart. So a tiny amount. The amount of weak acid that you start with, the degree of ionization is 0.0037%. So think about it this way. Weak acids are very weak compared to strong acids because strong acids ionize completely. The degree of ionization for a strong acid would be 100% ionized. Here, with a weak acid, for this specific example, the percent ionization is 0.0037%, so very small. So let's look at example 2. Okay, so we need the same information from example 2. We need the initial concentration of the weak acid, and we need the amount of weak acid that broke apart, which is X. So 2.3 times 10 to the negative 3rd. So again, what I need is the conjugate base at equilibrium, because that's the amount that broke apart, over the original, which is the concentration of weak acid that I started with. So it's going to be 2.3 times 10 to the negative 3rd over the initial concentration, which was 2.200. So let's see what that is. 2.3 times 10 to the negative 3rd divided by 0.2 is 0.0115. Two significant figures is what I'm going to have. So I'm going to say 0.012 is the degree of ionization. If I want to solve for the percent ionization, I'm going to take the degree of ionization, 0.012, and multiply by 100. Again, with two significant figures, it's going to be 1.2%. So again, a small number, but a bigger number than this. So that means this is a stronger weak acid than this. This para-hydroxybenzoic acid is a stronger weak acid than this phenol because this ionized more. This is the percent ionization. 1.2% of that acid is going to break apart into its ions. Much less than 1% is going to break apart of the phenol into its ions. So this is useful information to be able to kind of see how readily a weak acid is ionizing. You can solve for the degree of ionization or the percent ionization for any of these problems that we're doing.